So in the past lectures, we talked about how to find the areas of some fairly regular shapes, kind of those classic geometry shapes, rectangles, triangles, trapezoids, that kind of thing. So what do you do when you're faced with something like this that is not one of those regular shapes? Well, this is an actual real world scenario here. This was the floor plan of the living room, dining room area of my father's last house. And he and my mother decided they wanted to put in hardwood floors, take out the carpeting. So they wanted to get an estimate of how much it was going to cost. And to do that, they needed to know the area of the floor. So this is what you do when your son is a mathematician, math professor. He sent me the floor plan and said, hey, what's the area of this thing? Now, we're not going to actually do this one. Doing this was a little complicated and requires some trigonometry to handle the weird angles. But we will look at some more kind of straightforward examples. Let's say we have this floor here. And it's the same scenario, right? We want to install hardwood floors. We know the cost per square foot, and we need to know how much this contractor should bid. So to do this, I need to know the area of this irregular shape, and I don't have a formula for the area of irregular shape. So what I'm going to do, right, I'm going to take this irregular shape and I'm going to split it up into shapes that I do have formulas for, right? So for example, let's see, I'm going to add a line here that gives me a rectangle here, right? And that's good because I have a formula. I know how to find the area of a rectangle. I'm going to do it down here as well. That's going to give me two more rectangles, right? Now I have the little rectangle down on the bottom and that really big rectangle in the beginning, in the middle. So let's see. Let me label these, right? I'm going to call this region 1. This will be region 2. And this will be region 3. And now I need to find their individual areas, all right? So area 1 is a rectangle, and its dimensions are 36 inches by 26 inches. Okay, good. Now, I'm actually going to stop here for a second before I start throwing numbers around. Look back up at the units we were given for the flooring. All right, the flooring units are in square feet, not square inches. Okay, that's a problem. We always need to have our units consistent throughout the throughout all of our calculations. So what I'm going to do is, as I go along, I'm going to take all of these inches values and convert them to feet. Right? And remember how we do that. There's 12 inches in a foot. So 36 inches would be 36 divided by 12 feet. 26 inches would be 26 divided by 12 feet, and so on. All right, so the area here will be the length, that's 26 divided by 12, times the width, the other dimension. That's 36 divided by 12, and you get your calculator out. Now this comes out to 6.5, and let's be clear about our units now. We're doing this in feet, so this is 6.5 square feet. Okay, now let's do it again, and I'm actually going to jump. Let's do area 3 first, because area 3 is also not only is it a rectangle, it's a rectangle where I know both of its dimensions. It's 22 inches by 36 inches, right? So that'll be 22 divided by 12 feet times 36 divided by 12 feet, and that comes out to 5.5 square feet. Okay, now for this middle section, we're going to have to work a little bit. Right? I need to know this dimension here and this dimension here, and those values aren't in the diagram. Right? So I'm going to have to think about this for a little bit. Okay, so look, what I'm seeing here, okay, look at this top part. Let me clean up a little bit. This distance here, that one I know is this 124 inches. And I know this distance here, right? This is also 26, which means this distance here must be 124 minus that 26. Right? Again, you get your calculator out 124 minus 26 is, I believe, 98 inches. Okay, good. That's one. Now, how about the other one? See, I've got a similar problem here. I don't know this one, but look, I do know its pieces. I know that this piece is 148, and this piece is 36. Okay, excellent. So the whole has to equal the sum of its parts, right? 148 plus 36 is what? 184. And now I know my two dimensions, right? It's 98 by 184. All right, so now let's go and find the area. Area of section 2. And don't forget, we're doing this conversion here, right? This is 98 divided by 12 feet times 184 divided by 12 feet, which comes out to, if you do the multiplication, this is 125.2 square feet. Okay, now I can answer my question. What is the total area of this shape? If I add these things together, right, again, you're going to your calculator on this. This comes out to 137.2 square feet. Now, that's not the answer, right? We'll go back to the question. The question didn't say how many square feet is this thing. It said, how much is the total cost? Well, I know that each square foot costs $2.99. So the total cost will be 137.2 square feet times $2.99 per square foot. Remember, this is our kind of our unit analysis method now. The square feet cancel, and you do the math, do the arithmetic. 137.2 times 299. This comes out to $410.23, and that's it. That's my estimate of how much this floor is going to cost. Okay, so I've got another one here, very similar. A builder is pouring a driveway. Right, so immediately you think, okay, driveways are three-dimensional, right? Once you fill it up with this concrete. So I'm thinking we're going to be talking about area volumes here, right? But let's keep reading. He needs to pour the driveway with the shape in the diagram below. The concrete has to be 3 inches thick. What volume of concrete will he need? So yeah, I am looking for a volume, right? And it's what we call a right shape. The sides come up off of the ground at right angles. Right, to find the volume of a right shape, all I have to do is I have to find the area of the base and then multiply that by the height, by the 3 inches. Now, if you look at the diagram, you see we're having unit issues here again. Right? The dimensions are in feet in the diagram, but the height is in inches. So I'm thinking what I'm going to do here is I'm going to go ahead and do all the calculations for the area in feet. Don't worry about trying to convert all of these to inches. They're going to turn into weird decimals. Then at the very end, what I will do is I will take that 3 inches, divide it by 12. That'll turn it into feet. Then I can multiply it by the square footage to get the volume. All right, so we're going to do the same kind of thing we did before. I'm going to split this thing up. Right, I'm going to go here. That gives me region, we'll call this region 1. Down here, that's a rectangle, right? I like rectangles. Length times width, simple formula. And what can we do up here on this other irregular section? Well, we've got some options here. What I'm going to do is I'm going to split this up again. I'm going to divide this here into a right triangle. All right, so now let's see. Now I have Region 1 down there I have, let's call this region 2 in the middle, and I'm going to call this region 3 up here. And what do we get? The area of region 1 is 4 times 11. That's 44 square feet. I like to write the units in as I go along. I'm not fanatical about it. Sometimes doing that makes calculations too cluttered, and I'll leave them out. I do like to put them in when they're not really going to get in the way too much, because it helps remind me what I'm working with. So down the road, if I forget and I go to multiply something that's in square feet by inches, I'll immediately know I've made a mistake. I need to do some unit corrections. Okay, so how about section 2 here? Section 2 is 20 by 15. So the area of section 2 is 20 times 15. That's 300 square feet. Okay, now how about this upper part? What do we have going on here? I need to know this distance, right? Because that's the height of my triangle. So to do that, I know this length is the same as the 15 feet from the bottom. Okay, and I'm missing this guy. Let's call him X. Let's give us something to talk, so that I can talk about him. All right, I got a right triangle, right? So I'm thinking Pythagorean theorem: x squared plus 15 squared equals 17 squared. All right, 15 squared, that's 225. So x squared plus 225 equals 17 squared. That's 289. Subtract 225 from both sides. X squared equals 64. Take the square root of both sides. X equals 8. Awesome. Now I know the height of my triangle. Now I can get the area. The area of section 3 is 1/2 times 8 times 15. That's 60 square feet. All right, now I need this space back. So let me clean up my calculation here. And now we can add these together. That will give me the total area of the base. That's 404 square feet. And now I can find my volume. Volume is the area of the base, it's the capital B, times the height. The area of the base is 404 square feet, and here's where I got to do my little conversion. Times 3 inches divided by 12. That turns that into feet, and we get 101 cubic feet. And that's my volume. Right? That's the volume of my shape here. Okay, now when we're doing these, there are often more than one way we could approach this splitting it up business. Right? For example, if I come back over here, I could have looked at this and said, look, think about tilting this 90 degrees. Right? If we tilt this 90 degrees, hopefully you see it's a rhombus. It's not a rhombus, excuse me. It's a trapezoid. This is one base. This is the other base. This is the height. And we could use the formula for the area of a rhombus and have just done it in one pass. Right? That's fine. How you break it up doesn't matter. You should end up with the same final area, same total area for the figure either way.